Hey guys, welcome to my first tutorial on mechanics. This one's on translational motion, so that comes under momentum, conservation of momentum, impulse, and also center of mass. This is one of the four main parts that will be assessed in the 3.4 mechanics paper. Now obviously I'm not going to go from the beginning, that's like going back to level 2, but I'll try and explain concisely what is expected in the paper. So here it goes. Now let's just one of the fundamental principles of translational motion, the law of conservation of momentum, which states that during a collision or an explosion where there are no external forces acting on the system, which is a combination of two objects or more, the total momentum of the system before and after collision or explosion remains the same. So pretty much initial momentum equals final momentum. But let's take a case of it being in a two-dimensional sense. Say, like in this case, the collision of two pool balls. Now before collision, the white one is traveling at a constant speed towards a stationary black ball. Now since P equals mv, the momentum of the black ball is 0 because its velocity is 0. So the total momentum of this system before collision is equal to the momentum of the white ball. So here we've labeled it initial momentum, pi. Now after collision, say the white ball travels at 90 degrees to its initial direction, while the black ball travels at an angle to this direction up here. So the law of conservation of momentum in this case means that this initial momentum of the white ball must equal the addition of these two momentums after collision. Now since momentum is a vector quantity, i.e. is measured in terms of magnitude and direction, we can draw a vector diagram to illustrate this, like here. Here this horizontal vector is the initial momentum, pi, as above. And here we have the addition of the black ball's momentum after collision, which is at an angle. And we have the vertical vector of the white ball's momentum after collision here. Now since the momentum of the black ball and the white ball added together is equal to the momentum of the white ball before collision, i.e. the momentum of the system before collision, momentum is conserved. And if we wanted to figure out any of these components, say the black ball's momentum after collision, Pb, which is at an angle, then we simply apply Pythagoras theorem, which is a squared plus b squared equals c squared, or in this case, pi squared plus pw squared is equal to pv squared. So pv squared equals pi squared plus pw squared. Now, in the exam, at this level, we're not meant to be considering three-dimensional, so I won't go there. But it is still possible for us to be assessed on first-dimensional, so only one direction. But that's very rare. So in the case of answering an explanation question on this, it's always useful to state the law of conservation of momentum. So remember this. the law of conservation of momentum states that during a collision or an explosion, the total momentum of the system remains the same. As I said before during the conservation of momentum part of this tutorial, there are two types of collisions: elastic collisions and inelastic collisions. Now these two types of collisions are explained in terms of two things: momentum and kinetic energy. Now, as we know via the law of conservation of momentum, if there are no external forces acting on the system, then the total momentum of the system will remain the same. So, if there are no forces applied in either of these collisions, momentum is conserved. However, the difference comes around kinetic energy. In elastic collisions, kinetic energy is conserved. The problem is, kinetic energy is a scalar quantity, scalar, whatever, unlike momentum, which is a vector quantity. So kinetic energy is only measured in terms of magnitude, not direction. In inelastic collisions, kinetic energy is not conserved, but momentum still is conserved. Now, one of the questions that we were asked in class, not really in class, but that we were doing for revision, was a question on an exploding system. So, you have a ball, kind of cut in half, and it has a spring inside it. Now, picture a scenario where this ball is just stationary at first. Okay, so its total momentum is 0, and its kinetic energy is also 0. Now, when it explodes, the spring causes it to explode in one direction, we'll say one dimension, so one to the right and one to the left. Now, since it's an explosion with no external forces acting, so we disregard friction, then the total momentum of the system is conserved. So the momentum of this object in this direction is the same as the momentum of this half traveling in this direction. But what about kinetic energy? Since kinetic energy is a scalar quantity and not measured in terms of magnitude, we know that since the kinetic energy of the ball is not 0 after explosion, that kinetic energy is not conserved. Another point, though, in this question that normally some people wouldn't consider is the fact that there is a spring inside this ball. So there's elastic potential energy before the explosion. Now, after the explosion, the reason why kinetic energy suddenly appears is because the elastic potential energy of the spring is converted into kinetic energy. So there's an increase in kinetic energy in the system. Now, that in this question regarding the explosion of the ball because of the spring, it has to be explained in terms of the elastic potential energy of the spring being converted into kinetic energy of the two halves of the ball. This is very important. So, normally if it's an explosion or a collision and kinetic energy is not conserved, i.e. is an inelastic collision, then try and look out for any other forms of energy that will be present in order to form this kinetic energy, because as we know, energy cannot be created or destroyed. So this kinetic energy can't come from nowhere, it's got to be converted from something, in this case elastic potential energy. So whenever answering a question like this, take that into account. That's only regarding inelastic collisions. If it's an elastic collision, don't worry about it. because both are just conserve.